Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of determining slope. This is standard A.3A in the great state of Texas, and we are using item number 51 off the 2016 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a line that's passing through 2 points. We simply need to find the slope of that line. Well, it's pretty simple. If we go back to our reference materials, we will actually see this equation. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, we need to know that this is the slope. So when we're looking at either this equation or sometimes we'll see the slope-intercept form, right, we'll see y equals mx plus b. When we see a linear equation in this form, that's what we're looking for. And sometimes we remember this is the rise over run. It's the change really in y over the change in x. And sometimes if we have the graph, you can just kind of calculate it by looking at the graph if you have some points that you can clearly identify. So let's go ahead and label these, and I'm going to start by labeling this x1 and y1, and the second point as x2 and y2. Now what I'm going to show you in a minute is that it doesn't matter which set you start with. So I'm going to let's just do this. So my y2 is 12. My y1 is 7, right? So I'm following this right here. y2 minus y1 over x2 minus x1. So my x2 is negative 39, and my x1 is 26. Okay. So top's pretty easy. That's going to be 5. 12 minus 7 is 5. Bottom, negative 39 minus 26. We can eyeball that if we need to, or we can use our calculator, right? I'm going to compensate here. I'm going to make that 25 and 40, a little bit easier. So that's going to be negative 65. So it's going to be negative something. 5 goes into 65 13 times. And so we see that we'd have two possible answers that at least include the number just 1 and 13, and that's going to be A and C. Obviously A looking the better one right there. And B and D have 5 and 13, but they're not negative. Now, what happens if we were to swap these two? What if I were to make the negative 39 my x1 and the 12 my y1? Then if I were to make my 26 my x2 and my 7 my x1, does it make any difference? Well, I already told you it doesn't make any difference. So let's see. Let me write it right underneath here. So my y2 is going to be 7. My y1 is going to be 12. So it's still going to be 5, but it's going to be negative 5. And then my x2 is going to be 26. And then my x1 is going to be negative 39, so I'm going to be subtracting negative 39. So that's going to end up being a positive, right? So 7 minus 12 is going to equal negative 5. And then I'm going to get my 26 plus 39. It's going to be that same thing. It's going to be 65. So look at what happened here. So I've got my negative 5 over 65, whereas if I did it the other way, I did 5 over negative 65. So you could do either set as x2 and y2 first. All you're going to get is you're going to get a different operation from the numerator and the denominator, unless they're both going to be positive in one, then they would both be negative in the other. But either way, you end up with the exact same. So it doesn't really matter which way you do it, as long as the x1 and the y1 are paired up. So your answer here is going to be A.